So first, what do we use for mass atoms? We use atomic mass units, AMU. Okay. Atomic mass units, you can add the rest. I'm just going to put in the little shortening, AMU. So what is the mass of oxygen? So if I look at oxygen on my periodic table, it gives me a mass of about 16. Remember, no naked numbers. We always need to have a unit on stuff. So this would be 16 AMU. So if I have one atom of oxygen, it weighs 16 AMU. Now normally we talk about grams when we're talking about a mass of something, but we don't use grams when we're talking about a single atom, because that would make the number really, really bulky, really big, annoying number. Not like large, like 10,000, more like you'd have to take care of all of these zeros in front. Okay, so the mass of a singular oxygen, just one individual oxygen, would weigh this many grams. And that would be a very annoying number. Imagine me going into a lab and I go, okay, give me 2.7 times 10 to the negative 23 grams of something. It's not going to happen. Okay. So what we need, though, is if we're doing lab with compounds, with atoms, we need a way to actually use them in lab. I don't have anything that measures AMU. So we need to find a way to kind of bridge this gap between atomic mass units and grams. Now you're going to come back and you're going to go through and just put the atomic mass of each of these. So atomic mass, you're going to put the number and AMU. Okay, but right now we're going to keep going with the notes. So blank elements is one atom of an element that's stable enough to stand on its own, not bonded to anything. Okay? So our noble gases, we talk about how noble gases aren't reactive. Those are one of the ones that are very rare. Most elements need to be bonded to something else. We've talked about that whole octet rule, right? They want 8 full electrons. So we're going to call these our stable elements. Okay, and these are rare. Noble gases is an example of that, if you want to add that on there. Now, blank elements, or diatoms, are elements whose always travel in pairs, bonded to another atom of the same element. So we don't call these diatoms, we call these diatomic elements. Okay, so we've used this term before. Remember, you need to know all 7. Diatomic. Elements. Okay, so these are my gens, or they're the 7 on the periodic table, however you want to look at them. So hydrogen, nitrogen, oxygen, and the halogens. So what would be the mass of a molecule of oxygen? Well, O2 means I have 2 oxygens, and we said that I have each oxygen is 16 AMU, so 2 times 16, voila. A molecule of oxygen weighs 32 AMU. So now we're going to be talking about atomic mass and molar mass. So what we've done so far using AMU, this is atomic mass. Just the mass of that individual atom or that individual molecule. So this is atomic mass. Okay, so the mass of an atom, molecule, or compound in atomic mass units. Therefore, the atomic mass of a sodium atom is, you look at your periodic table, the number for mass is about 23. So 23 AMU. But remember, I said we need a bridge between atomic mass units and grams. Okay, we need something so we can actually measure sodium. Okay, whenever I did a lab, I had a chunk of sodium. If I want to know how many atoms are in there, if I want to know the mass of it, I'm going to need grams. So what we're going to use now, it's called molar mass. Molar mass is the mass of 1 mole of an atom, molecule, or compound in grams. So what that means for just this moment, when you look at the periodic table and I want to know the molar mass of sodium, I still look at the number for mass, but this time, instead of saying AMU, I'm going to say grams. So the molar mass of sodium is 23 grams. So this is the mass if I have an entire mole of sodium. So what is a mole? We're going to be spending a lot of time with moles. A mole is 6.02 times 10 to the 23 units of a substance. It's like a really big dozen. Okay? 6.02 times 10 to the 23 means 6.02 followed by 21 zeros. So 602, 21 zeros after that. Okay, the mole is a huge number, but that should make sense because we use the mole when we're talking about atoms. So if 1,000,000 atoms is the width of your hair, okay, and I want to be able to measure grams of atoms, I'm going to need a lot of those atoms. Okay? So what that means is that for every element, when you look at the periodic table, if I have 1.00 grams of hydrogen, that means I have 6.02 times 10 to the 23 atoms of hydrogen. If I have 12 grams of carbon, that means I have 6.02 times 10 to the 23 atoms of carbon. Okay? It's the same thing as saying if I have a dozen eggs, I have 12 eggs. If I have a mole of eggs, I have 6.02 times 10 to the 23. We're going to be spending a lot more time on this. If you struggle with that concept, that's fine. For now, all I need for you to be able to do is this. If I have 1 mole of carbon, I need you to tell me how many that is. Well, that is 6.02 times 10 to the 23 atoms of that thing. And because I have a mole of them, the mass of that mole, I can look at the periodic table again. 12. 12 grams. So this is that bridge. If I say I have a mole of something, now when I look at the periodic table, I can just call that grams. And that makes everything a lot easier. Okay? So you're going to need to read through these notes at the bottom. Okay? We're going to be talking about how to find the molar mass. So just like how I found the mass of O2 in AMU, so the mass of O2 in grams, well, it's 16 grams for a mole of one oxygen, 16 grams for a mole of the other. So 16 plus 16, once again, it's 32. Okay. All that this means is that I can use the word grams when I'm talking about massive elements now, because it's going to be grams per mole. All right. So if you look at the next page, when I say I want you to find the molar mass of each of these, well, first you're going to actually need the formula. So sodium fluoride, Na, fluoride is F. Na has a positive one, F is a negative one. Voila, that's my compound. Okay, NaF. So to find the molar mass, well, I look at the periodic table. Na has a mass of 23. Okay. And F has a mass of 19. So 23 plus 19 equals, and you put your answer. That's the molar mass. Okay. The only time I can get any more complicated is if I had NaF3. Okay, well now I need 3 fluorines plus the mass of sodium. If you look below these problems, okay, upside down, so that way you actually do the problem first and then you can reference it, I have each of those worked out, 1 through 6. Okay, so try and work them out for yourself and then double check. This is going to be crucial for a lot of things we do in this unit. It's very simple. You're just adding the masses of everything in that compound. Okay, but I need you to make sure you go through and you actually look at your periodic table. Make sure you know what you're doing. Your homework is to complete through number 16.